Hi, my name's Ian. I'm a dad. I'm an engineer. I've done some business. Um, and I'm trying to spread the word about this molecule. You can make it with green power. You can use it to do a lot of useful things, including substitute for diesel in a lot of cases. Uh, I'm I'm feeling kind of positive about this. But I was challenged the other day about the efficiency, right? The thermodynamic efficiency of this green fuel, right? Nitrogen, hydrogen together, it's ammonia. Um, Simple. And let me take you through this efficiency discussion, right? Efficiency. What does that mean? So first, green ammonia, where it comes from, you use turbines or solar to produce green electricity. You produce hydrogen, but then immediately combine it with nitrogen. The air is 78% nitrogen. Um, and when you do that, rather than having this light gas, which is very difficult to use, hydrogen is really difficult to use, you have a liquid. It's kind of like propane. It's pretty energy dense. It's easy to handle. It's easy to ship. It's safe. And we do it all the time. Uh, Traditionally, we made green ammonia, sorry, we made gray ammonia from natural gas, but it's quite simple to make it from green power, right? And and so if you put it in a ship, if you put it in a truck, it's green. It's green. The exhaust is nitrogen and water. It's green. But I was challenged on this. I spent some time thinking about it. The thermal dynamic efficiency of EVs, right? You take green power, put it into the battery, and the power to the road is like 80-90% of what you put in. So in theory, do you need to build fewer? Is it a better way to go, right? Versus, because there's this efficiency loss, you might have to build more turbines for the green fuel. You know, uh, a lot of people spend a lot of time and effort saying it depends. All right. So the answer is sort of it depends, but let me take you through all the analysis, or just all the topics really. So first, green energy is not scarce. So if you waste it, there's plenty of wind, there's plenty of solar. However, it is regional, right? So this color map, it's a free resource. I can share it if you want, but it shows sort of the wind intensity in different places around the world, and that impacts how much power you get out of the same turbine. So in like one of these redder areas, you could get twice the power out of the same turbine as Florida. So it's not rare, but it is quite different, which changes project economics. And shipping power, moving power from one region to another, is actually really, really, really expensive. It is far more expensive than a gas pipeline or an oil pipeline or even a hydrogen pipeline or an ammonia pipeline. It's it's I don't know, 200 times more. It's a lot. No, that's 20 times more maybe. And so we're not going to get into the economics, the trade-off between building here or there. Just know that there is a trade-off. So EVs will, to significantly impact greenhouse gases, would require a lot of new infrastructure. You need far more power distribution, and you need a lot more mining to produce the batteries. And where are we are today, we're not doing that investment. I'm not in charge of the policy, but like this is Ontario's plan. You'll see the orange go down a bit. We're refurbishing some nuclear reactors. Um, they'll come back online and get us back to where we were. Right, that's it. We're planning actually on taking renewables offline, and you can see that green line. Where we expect demand to go up, and honestly, we have no plan to fill that gap, which probably means we're going to use natural gas. Honestly, probably. Not my policy. That's where we are. It's not green yet, and the plan is not to make it green. In the US, uh, across all the power used, it's it's about 41% green, and that includes the nuclear. If you talk to anyone developing green projects, they'll tell you 50% of the time the sun is shining, they're curtailed. There's already so much solar and so much wind that they're not getting paid for it. So right now, the investment in additional green power is really low because the economics don't work. They're not getting paid for this. Um, Batteries will change that a little bit. You'll be able to store some of that green power and then sell it into the grid later at night. But that kind of doubles the cost. Anyway, that's where we are. And so to think about the scale we would need, right? Each person in the US uses about 12 megawatts of electricity. If you take all the power used and divide it up by the people, it's about 12 megawatts of electricity. Uh, Similarly, they use 22 barrels of oil each, which if you convert that to electricity, to power, that's 37 megawatts of oil. So even if you start talking efficiencies, you would roughly need to double the amount of electricity. And we're not making that investment. But that's what it would take, right? A huge investment in electricity. Now let's talk about mining growth, right? You know, not only do we have the batteries for vehicles, we've also got them, they're using them in the power grids now, right? So how much has the mining sector expanded to service this giant demand? Well, copper's maybe 5% up. To actually do this in style, we would need at least 200% growth. Maybe it's 5% up. That's not annualized. That's total over the last 5 years. Zinc, we need to double again. It's flat. Graphite, flat. And that we'd need to increase 10 times. Lithium, we need to increase 10 times, 1,000%. It's up 200%, but it kind of went up and then flattened. So the money is not going into this yet. Is that demand? Is it financing? Is it projects are difficult to develop? It's probably all those things, but that's where we are. And we also need to remember that EVs, they're okay for passenger vehicles, but they don't have that much energy. So a train, a transport truck, a tractor, it doesn't have the power to tow things long distances, really. Tesla announced the cyber transport, whatever it's called, in 2017, right? So that was 7 years ago. And yeah, they built it, but it's not out in the world. Now, if you look at where all the oil is used in the US, light cars are 23%. It's trucks towing boats, it's transports, it's aircraft, it's trains and buses. So this battery Tesla world, it's sure it's probably part of the solution, but we're not done, right? We still have most of the problem yet to deal with. And of course, every vehicle, it, like I just said, it takes a lot of mining, right? And mining is mostly, it's like explosives and big trucks. It's a lot of diesel. It's a huge amount of scope one emissions. So what's the payback on those in using a green vehicle? You see a lot of different numbers out there. I don't mean to argue whether this is the right number or not, but like lots of sources tell me a Model 3 has about 16 tons of carbon dioxide in the batteries. A barrel of oil has about 4.3 tons of carbon dioxide. Sorry, 0.43. Yeah. So that means there's like 37 barrels of oil worth of carbon dioxide in the batteries of that car. 37 barrels, right? So you need to drive a lot to break even, right? So is that 20,000 miles, 50,000 miles? People will tell you different things. And truthfully, it depends on where you're living, the type of driving you're doing. It depends, but know that there's a carbon debt in that vehicle. You're also dragging weight, okay? Those batteries weigh more than a combustion system. And so this is a graph showing light cars versus heavy cars and their miles per gallon. Right? So there's aerodynamics, there's other things in play there, but it's pretty clear that weight and fuel efficiency have a relationship. As you add more weight, right, the heavier cars are less efficient. And that's actually just physics, right? Force equals mass times acceleration, right? Mass, how much do your batteries weigh? How much have they added to the vehicle? Same with frictional force, as you're just driving down the road, right? The rolling resistance has to do with mass. Has to do with mass. So the work you do, the amount of energy you suck out of that battery, has to do with the mass. So when you're efficient at moving more weight, right? So do you take that into account? I think it needs to be part of what you're considering. Now, I live in Canada, so this matters to us. The temperature impact on an EV. As the temperature goes down, the battery range drops. Are there things they can do about this? Can they use heat pumps to warm up the batteries? Yeah, to a degree. But in our lived experience, everybody in Ontario, everybody in Canada, the EV does not last as long in the winter. It doesn't go as far. The battery pack power isn't there. Describe it as you will. Then, of course, as the battery gets older, it loses oomph, it loses its quality, it degrades. So some people graph this as time, some people graph it as miles. Um, I'm not sure if it is just charges or if it is time. I'm not sure. These three bars are showing, uh, do you charge the battery all the way up? There's different battery strategies. Regardless of what you do, it will degrade. It will. So right now, the warranties for batteries, they'll sort of guarantee that it will last at least after 100,000 miles, it will still give you about 70% of what it originally did. 70%. 100,000 miles. That's what they're targeting right now. Well, I mean, if you think about a transport truck, they go 750,000 miles, a million miles, not 100,000 miles. So again, for some things, yeah, maybe that's an okay stat. Not for everything. So efficiency, EVs, batteries, is it silver bullet? Right? We do this and we're done. Everyone needs to get behind this decision. We need all the policy. Is this it? We do this and we're done. Stop looking. I don't think efficiency is the whole story. It's you're just looking at one piece of what's going on. The grid is 41% green. You have a carbon debt. 30,000 miles? I don't know. But you have a carbon debt. You have extra weight. You have reduced capacity in the cold. You have reduced capacity as you go and use that battery further, once you get through that carbon debt. Flip that over, right? So is the battery better than a gasoline engine? Yeah, probably, right? Is it better than a hybrid? Is it better than a plug-in hybrid? Probably, depending on your driving style. But anything you do with battery, it still has greenhouse gases, right? And then green ammonia, made from green power, right? 100% green power, you make it with water and air. It's Is efficiency the thing we're talking about here, or is it greenhouse gases? It's green. It's simple, right? So I think particularly people who are in hard to abate areas, right, where there isn't a readily available battery solution. I think we should be talking about green power, green fuel, green engines, right? It's simple, it's green, it's available, it's safe, it's economical. Uh, Efficiency isn't the whole thing. We need to think about how green is it, right? Anyway, my name's Ian. I welcome your comments. If this is controversial, I hope not trying to rile anyone up. I just think we should look at some green fuels. Cheers.